Oh, hey! I didn't realize you joined me already. Well, this vlog today is going to be about organelle diseases and the different types of organelle diseases. So, me and my trusty little sidekick, Copper, are going to take you through the different types of organelle diseases. So, follow me and let's go ahead and look at this presentation. So, organelle diseases. I guess better question is, what is an organelle? Well, an organelle is what makes up a single cell. There's a bunch of different parts to it. You know, a couple examples would be like the nuclei, the mitochondria, which are like the power plants of the cell, the ribosomes, which are like the protein factories of the cell, and the lysosomes, which are like the garbage disposal of the cell. That is a simplified version. There was a different definition, however, it contained a lot of big words. So, what does it mean to have an organelle disease? It is one or some of your organelles are not working correctly, or they are dysfunctional. I apologize for my spelling. Two of the most common ones happen to be with the mitochondria and the lysosome dysfunctions. Approximately 2,000 people per year are diagnosed with an organelle disease because most of the time when they do go to the doctor, they don't realize it happens to be with organelles. They tend to give you anti-inflammatories or they diagnose different things until they take a much deeper, longer look into your body. So, let's go ahead and start off with mitochondria. Copper, are you excited to learn about mitochondria today? Yes, you are. All right, so mitochondria, it's an organelle found in all cells but red blood cells. It is referred to as the cell's power plant. It contains its own DNA molecule. They release energy to recharge your ATP molecules. So, what type of different diseases could be due to mitochondrial dysfunction? So here is a very long list of diseases. You have neurodegeneration, you have strokes, you have demyelination, you have epilepsy, ataxia, Parkinson's, migraines, cognitive decline, psychiatric symptoms, hearing deficit, cardiomyopathy, conduction deficits, kidney dysfunction, muscle weakness, cramps, tiredness and exercise, liver disease, sensory or motor neuropathies, visual impairment, diabetes, malabsorption, diarrhea, infertility, premature menopause, anemia, immunological defects. Whoever would have guessed that there was so much that could happen with a mitochondrial dysfunction? It's just unbelievable how many diseases there are. So, mitochondrial diseases can manifest both in children and in adults and can present in various organs, including in multiple organs that may have no apparent functional links to each other, such as the brain and liver, or pancreatic B cells and the auditory systems. Sometimes manifestations only affect one tissue, such as the heart or the optic nerve. Children may recover from one phenotype and later develop another. For example, in Pearson syndrome, the primary manifestation is exocrine pancreatic dysfunction and megaloblastic anemia. And the survivors may later develop brain disease. Who would have known? Typically, these disorders are very progressive. And this is from this gentleman with the last name of Sumalian, 2018. You will see his reference in my reference page. All right, now going back, let's go ahead to lysosomes. So, lysosomes contain enzymes to promote hydrolysis. They can break apart large nutrient molecules. Their nickname is the digestive bags of a cell, and they also destroy microbes that invade the cell. Now, I'm going to get my little trusty sidekick over here so I can show you kind of like what a lysosome does. So first, they can break apart large nutrient molecules. All right, copper. Where'd you go? There you are. Does copper want a treat? So just like how a lysosome can break down nutrients, copper is going to show us, he's going to show us kind of like what they do. They help feed the cells by breaking down the nutrients. And now, we're going to show you what happens when there's a microbe that invades the cell. Here is our microbe. Copper's possum that he's absolutely destroyed. But we're going to go ahead and we're going to give it a toss and show him what a lysosome would do. Copper, hey, go get it. Okay, well, normally he would go and attack this thing and rip it to shreds, but currently he is enjoying his treat. So unfortunately, that did not work out as planned. Let's try this again. Copper, hey, go get it. I guess my helper wants to be very unhelpful currently. Okay, so back to the presentation. What are different diseases due to lysosome dysfunction? There are Gaucher disease, which is lipids buildup in organs like spleen and liver. Niemann Pick disease, Fabry disease, Tay-Sachs disease, which that is fatty substance builds at toxic level in brain and spinal cord. Which with that disease, or most of these diseases as it is, they are passed down through genetics and are extremely rare. But with Tay-Sachs disease, it happens to be very fatal. When you find out with a baby that they have Tay-Sachs disease, they only end up living for a few years, which is very unfortunate. You have MPS diseases, which is mucopolysaccharidosis diseases. You have Pompe disease, and you have Parkinson's disease. Well, Parkinson's disease was also with mitochondria as well. Who would have guessed that two of these could have brought the same disease? But let's dig into the reason with the lysosomes why there's Parkinson's disease. So, from another one of my different sources, here is this. Synucleinopathies, a group of neurodegenerative diseases including Parkinson's disease, are characterized by the pathological deposition of aggregates of the misfolded synuclein protein into inclusions throughout the central and peripheral nervous system. Intercellular propagation from one neuron to the next of synuclein aggregates contributes to the progression of the neuropathy, but little was known about the mechanism by which spread occurs. This study demonstrates that TNTs play a significant part in the intercellular transfer of synuclein fibrils and reveals the specific role of lysosomes in this process. This represents a major breakthrough in understanding the mechanisms underlying the progression of synucleinopathies. And this was from an internet article through our library with the title of Parkinson's Disease, Tunneling Nanotubes Between Neuron Enables the Spread of Parkinson's Disease Via Lysosomes. And it was published in 2016. Well, for the presentation, that about does it. Here is the page. Right here. And also got some of our good stuff from our trusty old textbook. All right, Copper. Say bye to everybody. Thanks for joining in. And you know what? I'm going to get back to watching Jurassic Park 3. Thank you.